Bismillahirrahmanirrahim. Last time we talked about rotations. Rotations, if you recall, were one of four types of transformations. Transformations being translations, reflections, rotations, and dilations. And if you recall, when we talk about rotations, there are two important things that we need to know. Whenever we are rotating an image, we have to know two things. We have to know the center of rotation. We have to know the center of rotation, that is the point, rotation, the center of rotation, the point about which we are rotating. And secondly, we have to know the angle of rotation. So anytime we are rotating an object, we have to know the center of rotation, the point about which we are rotating an object, and we have to know how many degrees we are rotating. If you recall, by convention, when we rotate in geometry, geometric figures, we rotate counterclockwise unless otherwise stated. So by convention, we rotate counterclockwise unless the question asks to rotate as clockwise. Okay. And so for rotations, we have to know the center of rotation and the angle of rotation. And typically we rotate objects about the origin here. We don't have to rotate objects about the origin. We can rotate about any point. We can rotate this triangle about this point, for example. And so we rotate like this way. Or we can rotate the triangle about this point. So we rotate the object this way, or you rotate the object that way, either counterclockwise or clockwise. So we can rotate about any particular point. And if you recall, when we rotate objects, what we're doing is we connect the point of rotation, the center of rotation, to each point in the figure, and that serves as kind of like you're holding it with the piece of wood, and you're kind of like rotating about it with the forceps or something like that, and then we are rotating this whole object this way. So, and then we rotate this point P, for example, the same distance to whatever angle you're rotating. So if you were to rotate this point P like this way, this would be the angle of rotation, and the point P would be rotated to this particular point, the P prime. That would be the image. So the pre-image to image would be rotated that way, and this would be the angle of rotation. You can call it whatever. You can call it theta, alpha, or whatever angle you want to call it, or simply the angle of rotation. So that's how we rotate objects for any particular degrees and about any particular point. Then we talked about specific rotations, and that is, we oftentimes rotate objects by 90 degrees. So you can rotate objects by 90 degrees, 180 degrees, 270 degrees, and if you go full circle, that would be 360 degrees. And I suggested for last time, rotating 90 degrees is very easy in a Cartesian when you give an ordered pair. That is, whenever you rotate counterclockwise, that is, whenever you rotate an object counterclockwise by 90 degrees, all right, so what you do is, if you remember, do you remember? So what you do is first you take the y, ordered pair y, and you negate the sign. If it's positive, you make it negative. If it's negative, you make it positive, and then that y would be would take the place of x, and then you simply then place the x where the y used to be, like this. All right, so you don't change the x, you just simply move it to the y direction. So you take the y and then you negate it, and then you put it in the place of x, and the x will go in the place of y. And that's how you rotate objects by 90 degrees. That's a 90-degree rotation in a counterclockwise direction, like this. So that's how it is done. So if, let's say, we wanted to rotate this particular triangle, P, Q, and R, and we're rotating triangle P, Q, and R by 90 degrees counterclockwise. So, and that doesn't need to be said if by conventions that's what we're going to do. So we're going to rotate this object by 90 degrees counterclockwise. Then all we have to do is we take each point, and this is about rotating about the origin, okay? And the center of rotation is the origin. The center of rotation is the origin, okay? Or 0, 0. Ta-da. Now, here we have it. So the way we do this then again is we take each point over here, we apply this particular rule, by that. So we can just go methodically, we can put P over here so we don't make any silly mistake, and then P will become P prime, right? In this case, if you take this and make it a -1, right, this becomes like -1, and that we place the negative. It happen to be the same numbers, so it doesn't matter. So, and then X will become this. So that's P becomes P prime. And then we will have Q. Now Q is 4, 5. And then if you rotate that by 90 degrees, make the 5 a negative and put that in place of X, and the X will go over here. That will be Q prime. And P, Q, and R. R is 5, 1. And if you rotate that by 90 degrees, we get R prime, and that's going to be, make the 1 negative, and the 5 will take the place of Y like this. Okay, so now let's plot this particular point. So P prime is -1, 1. So here's, let me just say this is -2. So -1 and 1, that's P prime. And Q is -5 and 4, that's -5 and 4. So that is Q prime. Alright, so that's -5 and 4. And then this, let me just put this here, P prime. And then R is -1 and 5 over here. So here's -1 and 5. And that's R prime. Okay, so then I can connect these 3 points to get us the new triangle, the image from the pre-image that we have. So here we have this. All right. Now notice this Q was rotated 90 degrees over there, and then R is rotated 90 degrees over here, and P is rotated 90 degrees over here. Now the angle of rotation is right here, see? So that's a 90-degree angle. You follow? So this one was rotated, all of these were rotated by 90 degrees, and R went all the way over there. So if we rotate this triangle by 90 degrees, that's where we'll end up. I just wanted to bring to your attention, this is not the same as reflecting about the y-axis, because if we were indeed to reflect this particular triangle about the y-axis, P would go over here, Q would be go over here. Let's say this is like 4, 1, 2. Let's say go over here. All right. So, and if I did that right, so 4, 5. Like so, it's from here to here is 4, right? So if I went from there to there is 4. I got that right, I think. And then here 5, 1 would become 4, 5. So 5, -5, 1. Will be like this. So if I were to just reflect it about the y-axis, this is what I would have. So this is the reflected image about the y-axis, if I did this correctly, you know what I'm saying? So no, I didn't draw this properly. It's more like that. Okay, so this will be a reflection about the y-axis. Clearly, as you can see, reflection is not the same as rotating it by 90 degrees. Let me try to make this a little neater. Okay, so this would be the reflected image of this particular triangle about the y-axis. So the rotation is different than reflecting it about the y-axis. The other thing I wanted to bring to your attention is that we can again rotate this over here by another 90 degrees by following the same formula. So if you wanted to do this again, we could rotate this again by 90 degrees. So this would be P double prime. So let's do that. Let's rotate it again by 90 degrees. So let's say, so this would be P double prime. And then I would do again here, flip to make that negative. That's -1, and move this one over, right? So this would become -1 like this. That's P double prime. And this one would be Q double prime. The Q double prime would be make the 4 the negative and put that in the place of X. So it would be -4, -5 would be here. And then this would be R double prime, and that would be make the 5 a negative, right? So that'd be -5, and the X would just switch spots with the Y. Okay, let's draw this one out. So -1 and -1, so that's going to be P double prime, and -4, -5, that's -4, and that's -5. That's Q double prime. Right, negative. I hope I did that right. I hope you're watching me, so I don't make mistakes. -5, and -1 is right here, and that's R double prime. So if that's double rotation. So I've rotated again by 90 degrees. There we have it. So here I rotated it by 90 degrees, and again I rotated here by 90 degrees. That's basically a 180 degree rotation, isn't it? So between here and here, these two images, that's a 180 degree rotation. That's kind of fascinating, isn't it? And then if I do it again, I would bring it here. If I do it again, it would fall right back into the original image, wouldn't it? So this is a rotation by 90 degrees in the Cartesian plane. Okay, here's an interesting question. This is an example from the book. I think it's a pretty cool example. This one says, rotate triangle ABC 180 degrees. We're assuming it's going to be counterclockwise by convention. 180 degrees about the point -5 and 3. Okay, so I've drawn this out. This is triangle ABC. Those are the ordered pair. Now here, remember, this is -2, -4, -6, -8. This is a bigger Cartesian plane here. So zoomed out a little bit. So this is A, B, and C, and that's point P. So we are asked here to rotate about point P, like, okay, 180 degrees. So it's like 90 and then 90, but across this point P over here. Now, we said just now a little bit ago that you can rotate an object about any point. You don't have to rotate about the origin. And but that's going to be tricky, right? So how do we go about doing this? Because we kind of know how to rotate objects about the origin. Like if you had a 90 degree rotation, so all you do for a 90 degree rotation, if you remember, is you make the y the negative. So you remember that. So you make the y into a negative, and you put that in place of the x. So you have -y, and then you have, you know, the x in its place. So x will take the place of the y. So that's how you do a 90 degree rotation. So counterclockwise. But that's about the origin. And how do we do that? Well, one thing you might be thinking is, maybe we can pretend that this is like a new origin, and maybe we can like do the same kind of trick to this. So, well, that's kind of the thought process, but the thought process is the same thing. See, this is for a 90 degree rotation. It's like this, okay? But what we do here is, what we do is this is what we do. What we do is the first thing, we drag P and put it here to the origin. It's like bring P over here and to the center of rotation. So P here is the center of rotation, and just kind of like drag it over here to the origin like that. Just bring it here, and then when you do that, then pretend the P's, everything is detached. So then bring everything the same way. So drag A, drag C, and drag B in the same direction. So move like everything, instead of moving the origin to P, move P to the origin and drag everything along with it, so to speak. In other words, translate P to the origin. Slide it or glide it to the origin like this. So P becomes the origin over here. Okay, so move the center of rotation to the origin. Slide it. And how do we slide stuff? Well, we use vectors to slide things, to translate, don't we? So we can use vectors to slide or glide or translate, and to P over here, and then we use the same vector to bring A, B, and C along with it. So in other words, redraw the whole thing, but based on here. So you take all of this, basically move it this way, so that P falls on the origin, and everything else falls where it's supposed to in respect to P. Well, so first step is going to be to move the center of origin, move the center of rotation to origin. So move P to the origin. Okay, so how do we do that? We do this using the vector. Now, what vector do we have to use to move it there? Well, the vector is going this way, right? You know what I'm saying? It's going like this way, correct? So we're going to have to move in the x direction. It's like -5 from here to here is 5 over here. So we're going to have to move right. Every vector has two components, x and y. So in the x direction, we would have to move 5 units, right? So in the x direction here, change in x is 5. And in the y direction, we have to go down by 3. So the change in x is 5 and change in y is 3, right? So that's -3. Now this is, remember, it's not negative 5 and 3. It's not an ordered pair. Now we are creating a vector that would take this point to the origin. And to do that, we're going to have to move right by 5 and down by 3. You follow? So the component form of the vector that will take P to the origin is 5 and negative 3. Great. So then the P becomes over here. The new P will be over there, right? All right. So you can call it like P origin, P sub 0, or P sub O, P origin, right? That's kind of like my lingo. So we did that. So if you do that, then you can use the same vector to move A, B, and C, where they would be if P was the origin, right? So then we apply the same vector to A. So let's see, what is A? A is negative 8 and 5. And we apply this vector V, which is 5 and negative 3, right? So so this A, and then so this A prime. Let's call this the new A, correct? Or you can call it whatever you want. The new A. I'm going to call this A prime, okay? Because it's like that. So A prime. This would be negative 3 and 2. There we go. I think I did that right. And B, which is currently negative 6 and 9. If you apply the same vector, 5 and negative 3, so the B prime would be, here we go, negative 1 and 6, if I did that correctly. C is going to be negative 3 and 6, and apply the same vector, which is 5 and negative 3, so that would become C prime, so that's going to be 2 and 3, like this. Okay, so let me draw this out. So there we have it. So now I've moved this triangle along with P. So see what we did over here, we moved the P over here, that became the new P, and moved everything in relation to P same way. So I took both of these things and moved it here. Now we are ready. Now we can rotate this particular triangle. Now we have to do 180 degrees over here. In other words, we have to do 90 and then 90, okay? So we do 190 and then we do another 90. That would be 180 degrees rotation, right? And then once we do that, we have to go back, right? We have to reverse the vector, correct? So let's do this 2 90-degree rotations. Okay, so to do 90-degree rotations, I have to flip it once. Okay, so here, so 2 becomes negative 2 and negative 3. All right, so I make this one negative and put it in place of x, and x goes into place of y, and I do it again, 90-degree rotation. Be careful here, don't make mistakes. That becomes 3, reverse that 3, and now go over here, and then negative 2 will take the place of x. Okay, so I'm going to do the same thing 2 more times, like this. Okay, here I did it. Okay, I saved us some time. Okay, so I did 90 degrees rotation 2 times. So I took this triangle about the origin, I rotated 90 degrees and rotated 90 degrees. I got those ordered pairs. But we're not done yet, right? If you do that, we will get the triangle that's, let me just draw this particular triangle over here. So this is 3, negative 2. This goes by like here. This is like 4 now. All right, like here. So that's 3, negative 2. And I have 1, negative 6. That's 2. That's 1. Okay, that's whoa. That's that goes by. That's negative 4. And negative 6, 1, negative 6 right over here, and then negative 2 and negative 3. So that's negative 2 and negative 3 over here. So 3, negative 2, 1, negative 6, and negative 2 and negative 3 right here. So here it is. That's my triangle over here. So here's my double 90 degrees, 180 degrees rotated. So this is this particular triangle rotated 180 degrees. Okay, now then we have to take it back, right? We have to apply this vector, make it back, right? It's because everything's now in terms of origin, we have to put it back. So we take these 3. Okay, so let me put them over here. So get that we have 3, negative 2, and then 1, negative 6, right? And then I have negative 2, negative 3, and then I have to apply the vector that will take them back, the reverse vector, the reverse of this vector. Okay, what's the reverse of v vector? So well, we can call that vector w vector. Okay, the vector that's going to go take p back to where we're backwards, right? So what will take p back to over there? Well, that's easy enough. You have to go left -5, up 3. So the reverse vector, let's call that vector w. That's going to be you have to reverse it, go -5 and go up 3, right? So backwards is -5. So we have to apply that vector to all 3 of these to take the triangle back to in reference to the way the question was originally written. Okay, we can do it. We can do it. Okay, so here we go. So that's going to be -2 and 1, and that's going to be -4 and -4 and -3. I hope I don't make any silly mistakes here. That will look really bad. So, and then I have -7, and if I did that correctly, that's going to be like 0. Okay, so okay, now I can draw this out. Okay, I'm going to draw this out. So it's -2 and 1. It's a pretty messy picture here. -2 and 1, and I have -4 and -3, which is over here. -4 and -3, and I have -7 and 0. Whoa, it's like -7 and 0. There I have it. All right, so you can call these whatever you want. All right, so here we have it. Okay, so this was A, the original A. So this was A, and then that became this final point, and I'm just going to call that A double prime here. So 2 -1, 2 +1. This is like A double prime. I'm going to call this one A double prime. So this is B double prime, and this is C double prime. So, and this is B double prime. So that B became this B over here, and C became this C over here. So C, when you rotate it, it became that. A, when you rotate it 180 degrees, became this. There you have it. So this last triangle, the white triangle that we drew, is this original triangle ABC over here, rotated 180 degrees about this point. So we went kind of roundabout way. So what we did is first we moved P down here. Along with it, we moved the whole triangle down over there using a vector. Now P was at the origin, and we rotated about the origin 180 degrees. And then once we had the rotated triangle, which was here, that was the rotated triangle, rotated about the origin. Once we did that, we moved that back by the same vector that we used, and that was vector W, reverse vector, going this way. Okay, so this was because of the vector W. So this is vector W, W like that, and we got the image back in reference to the way the question was originally written. So this is the final image after it was rotated about, not the origin, but by point P. I thought that was actually a very beautiful question. I hope you enjoyed. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.